Okay, our third panel is going to be about testing and tooling, and our moderator is Todd Anglin, who's Executive VP at Telerik, who produce tools for developers and developer teams. You may know them best for Kendo UI and Icenium. So take it away, Todd.
Great. So I am strictly the timekeeper up here. Telerik obviously creates a lot of tools, but I think our panel, which is quite diverse today, has the full perspective. We've got about 6 questions total in the moderating queue, so we'll probably start there to kick it off, but I definitely want to make this as interactive as possible. I know we're starting to stand between you guys and alcohol, which is always a great place to be. So to kick it off, I will let the panel introduce themselves. I was introduced Todd Anglin, work with Telerik. You guys know us for Kendo UI, but I'll let the panel introduce themselves.
I'm Pavel. Oh, no, sorry. I'm Pavel Feldman, software engineer working on Chrome developer tools.
Hey, I'm Yehuda. I work on Ember. Mostly these days, I've historically worked on jQuery and Rails.
Hey, I'm Anton Kovalyov. I work at Mozilla. We make a web browser and a mobile operation system, and I work on Firefox developer tools there.
I'm Jonathan Lips, and I work at Sauce Labs, and this year I've been working on an open source project for mobile automation called Appium.
Hi, I'm Brian. I work on PhoneGap and Cordova and a thing called Topcode at Adobe.
Very good. So very diverse panel. Guys, kick it off. First question here. It's from Rob. And the question is basically asking, how does Google test its mobile products? So what are the things you use to test your mobile products? But to make it a bit more generic, I think we can just kind of open it up. How do you test your mobile products today? What are the techniques you use to ensure that you're delivering a good mobile experience? So we'll kick it off linear and start here with Google.
Okay, so I'm working on Chrome, not really any mobile app or web app for Chrome, but we use the same tooling for testing Chrome regressions as our apps are using, and that's telemetry, which applies pretty much to everything WebKit Chrome based. It has been mentioned earlier. Check out it on the Chromium Works site, there's documentation for it. It's a lightweight script framework with a very friendly Python framework front end. It's based on remote debugging protocol. You can automate things there, simple automations, navigations, scrolling, and you can capture all of the data that Chrome DevTools can capture of those pages and all of those scenarios. So you get a full-fledged timeline there, and everything is JSON-based. You can analyze this data. And we internally building charts, regression charts for that, a lot of perf data. For each of the commits, each of the builds, we see what has happened there, and we can go back and blame a CL. So that's pretty simple, and that's what we expect everybody to do.
Hey, so I pretty much use your product for testing. I don't have a huge array of physical devices and little startup, so definitely like to test on as many pieces of hardware as I can, and you guys have a really good group. And if I was much bigger, I would want to have more devices to test with, but sadly not.
Okay. So I work on Firefox for desktop, so I don't really work on actual mobile web apps. But the closest we have, I guess, to the testing mobile web apps would be Firefox OS. And as far as I know, we have another Mozilla here, so if I'm telling something stupid, or when I'm saying something stupid, correct me. I think we use the same framework as our own written framework as we use for Firefox for desktop, which basically simulates all the events you can have. And as all testing frameworks out there, no offense to any framework writers, it could be way better. And it's partially our job as well, as Firefox developer tools engineers, to make it better. So far, it's getting there. But yeah, that's what we use. Unfortunately, I don't have a better answer what we use for actual testing our mobile web apps, if Mozilla has any mobile web apps. Does it? No.
This is a highly qualified panel.
Yeah. So At Sauce, we use this project called Appium, which if any of you guys have done testing of your web apps, you might have used Selenium. Appium uses the same protocol, and it can test the native mode of your application, so native Android or native iOS applications. It can also test if you have a mobile web app, you can use the native web applications, Safari and Chrome, and also test kind of the hybrid views of each of those. So you kind of get all the levels of your application, especially if you have a hybrid application. That's pretty hard to do, so works pretty well.
Okay, so on the PhoneGap project, we built a big-ass wall, and we stuck a shitload of phones to it, and we wired all those phones up to a Mac Mini, and every time a commit lands inside of Apache Cordova, which is the open source part of the project, we compile PhoneGap, we load it with a web app that has a bunch of Jasmine tests. Some of the tests are in QUnit, but that's just historical. And then we post the results of those tests back to a couch. And you can see this stuff, I think it's at like test.cordova.io. And so you have to test on real devices. You can't get around that. Devices have sensors, and you can test for things like, say, is there an accelerometer, but you can't actually test the accelerometer data coming through unless you build a robot, which we're talking about with Sauce. So we're doing that. It's an open source project. It's called Medic. If you're interested in automating, pushing native apps to phones and then getting test results, we can talk about it later. There's another project at Adobe called Topcoat, which is a CSS project, and we're using telemetry from Chrome to get the data out of that. So we have a custom build of Chrome, CEF, and when we land a commit into our CSS, we add that to a page, and then we load it, and then we add like 200 elements to a page, and we load that, and we scroll it, and we measure load time, layout, and frames per second. And so we know in each commit that this CSS is actually getting faster and faster. And all that's open source too. It's at a Topcoat organization inside of GitHub.
I have a follow-up. It's kind of a question or more like a rambling. So I feel like there's a notion in the mobile web world where you have to test on the actual device. And this is true. You have to. You can get away from that. But I don't know if we're actually working towards reducing the amount of testing we need to do on actual hardware, because attaching shitload of phones to the wall doesn't scale when you have 200 engineers, because then you have hundreds of commits per day. Every commit launches a phone, and then you wait for the test to be done in like what, 2 hours, 10 hours. So shouldn't we, like as a tools developers, I guess, work on reducing the hardware dependency or adding, and I'm just throwing ideas because I haven't actually thought about that, or adding better simulation to devices, or even add better simulation to the low-grade hardware, to the hardware limitations, so that I could say, run this test, and then run this test when you have only 2 megabytes of memory left. And so this question is actually mostly to you guys. Yeah.
So I do think that simulators and emulators provide a good kind of base level of testing. There are actually advantages over using real devices. Things like making sure that you have a clean, stable environment, that you're really only testing the changes in your code, making it easier to run as part of your continuous integration on every commit. Maybe you want to run your full battery of mobile functional tests on emulators because that's cheap and easy, but you don't want to run it on all of the huge matrix of real devices. You want to do that when you're ready to cut a release or whatever, and then have a little bit more confidence around it. So I think you can view it as kind of a two-phase process, where you do more of the cheaper resource, which is emulators, simulators, which you can virtualize the shit out of, and then less of the more expensive resource, which is sticking devices on walls.
Yeah, the device wall does not scale. It's true. But you got to do it. So the simulator emulator thing, the only problem with it is that you're in a virtualized environment, and then you're probably on good hardware with good network with lots of memory, which is basically what mobile isn't. And so
I think Anton's point was hey, people who make simulators, maybe you could not have it emulate a perfect environment.
Yeah.
Right?
Yeah, I agree. It'd be nice. I know the Boot to Gecko simulator, or what was it called? R2, it was a terrible name. What was it called? R2D2B2G or something crazy? Yeah. Yeah. Anyways, the Firefox OS simulator is kind of cool because it is that, right? Like, and it is the environment, whereas like iOS and everything is not quite the real thing. And the other problem is like all these sensors, like I guess we can just chuck fake data at it, hope that it is doing the right thing, but it's a complicated problem for sure. There's another way to test, and that's just release often. It's a bad solution.
There's another aspect to it. Everything we were talking about today has this performance aspect, so everything is performance. When we were talking testing, testing is testing, and testing is testing for performance. And the latter is important to all of us. And the latter is challenging to emulate or simulate. We've been doing sampling profiling for Intel and ARM, and the pictures that we were having were just radically different, and hardware accelerated stuff is entirely different. So if you're interested in the end result and you're interested in not regressing the end result on the device, as of today, there's no other way other than getting to the hardware and testing it there.
It's like one other thing to throw out there for people, but like measuring is like super important because then, you know, that's how you get to a better result ultimately. But the problem with all this is that it requires a lot of boilerplate setup that developers just do not want to do. When you're writing code, you don't want to go put on your profiler hat and start profiling. You want to write code, right? And you ideally are notified that, hey, something just got slower. Fix that instead of like finding out after you deploy out of context in a context switching. So there's definite need for better tools that happen during authoring time.
I think we'll get there. Telemetry is a perfect first step there because you assess performance as your app runs at the script running. WebDriver is just not evolving fast enough to capture all of that data, so telemetry is kind of a fast and hacky way for WebDriver plus the instrumentation. And running profilers and raising flags, doing all of that, that will all come. We're just only starting there.
So I have an honest question about profilers in general, which is, do people who write the profilers actually, is there like any user testing at all? And I don't mean like get your grandmother, but I mean like get me to sit in front of it and look at me trying to use a heap profile dump, right? Like if you just watched me for 10 minutes, I think you probably have 10 good ideas on how to make it better. I guess it's a question for Pavel.
Yeah, so okay, so memory profiling is hard, and no matter what platform you're in, be it native or Java or JavaScript, historically, memory profiling has been a separate task that you were forced to do. You didn't want to do that just because you always are forced to do it because you are out of memory. And you don't want to do it because it's hard and challenging because memory heap is a graph, and it's really complex. But I guess what you're talking about is Chrome DevTools UX for heap profiler. We are making some good improvements there. Some of them were recently demoed. We are aware of certain complexities there and certain degree of education that you need to gain the hard way before you get a sense of it. We filter out the garbage of the UI and of the heap. We remove unnecessary data. But you shouldn't fool yourself. It's a hard problem to tackle, and it will remain hard. Also, we are trying to make it simpler for you.
You know, one thing to throw on top of that, this is something sort of like we're ashamed of in the top-coat part of the reality. We're using telemetry. We love it. It works really well. It's a good way to get a measurement, and our assumption, which is probably not true, is that if we're using telemetry data, that means we're using Chrome, and that means we're measuring Chrome. And we figure if it's getting faster in Chrome, it's probably faster in other places. But that's an assumption, right? Like, and so we need these APIs actually back in the browser proper. We need them in, IE.
So a couple of examples.
Not calling out IE specifically.
So a couple
more.
I could get a little more concrete. So a couple of examples on the heap profiling thing. One of them is, so heap profiling basically tells you if you're leaking memory. It says like, hey, you after running a GC pass, we can see that there's X amount of memory. But actually the thing that sucks about garbage is not the garbage that's left. It's often just like you're generating a ton of garbage and it's causing jank. And as far as I know, none of the heap profilers allow you to say like, hey, I want you to tell me what's on the heap now, but don't run a GC first, right? And this is not a very complicated thing. It literally means don't run the GC first, and then tell me the same thing that you're telling me already. and use the same differencing tools to do that. And I think there's things like this that, I mean, I wonder how the Chrome team is. Surely the Chrome team and the Firefox team occasionally run into issues where they're writing some self-hosted code and they generate a lot of garbage. They want to know what the garbage is. I'm curious what they are doing for these types of problems.
So this particular one, the underlying implementation is that you can visit all your heap within the GC, and that's the only way you can visit your heap in V8. You could work around it, and I think this particular thing just did not come up. To answer your previous question, our clients, the biggest client that we have is Gmail, and all of the headache that we were getting was Gmail, and it was more than a gig of RAM before they started using it, and then it was like a back and forth iterative process. Gmail was improving, tools were improving. So in-house, we were working like with large web apps where memory matters most.
So you were worried more about applications that had a lot of persistent memory and less about just like a bunch of memory that got created as part of, like during scrolling, let's say.
We're just picking Gmail as the largest, like, crazy app out there.
To answer this question from so I run into these issues when writing Firefox front-end code since it's all JavaScript. And what I do is I usually cry myself to sleep. Then I wake up and use our very basic tools that we have to kind of fix the problem. So it's not the answer that we have a solution for this. My answer is that everything pretty much sucks. But we're working towards improving that. And so Yehuda already gave us really good feedback, but if anyone else has feedback on how the memory profiling, the what's in the garbage and other things could improve your lives, that's really helpful because I used to be a web developer. Now I mostly work on the Firefox for desktop, so I don't do that much web development. So we need input from the outside.
So I think that's sort of a fair point to transition almost as a natural follow-up. I mean, I think we would all agree dev tools and browsers have come a long way in a very short time, but they're clearly not done improving. From your perspective, working with them, really digging into them, what are the things we most need still in browser dev tools? And this can be Chrome or just across browsers in particular.
Yeah, hey, this is my topic. Okay, so in my opinion, so DevTools have come a long way, and the biggest gap in the current DevTools story versus like some native tools is there's a very limited ability for framework and library developers to help the DevTools present information in a more useful way. So let me give you a simple example. If you are writing, a lot of the code that's inside of Chrome is actually written in JavaScript. And for example, you might imagine that for each for native arrays is written in JavaScript. But of course, when you press the down arrow to step into your code, you don't actually see the native code. You just see your own code, because the browser has the ability to say, I do not want to show you this internal code. But as a framework author, I don't actually have any ability to tell the browser, like, hey, unless the user really wants to see this, they shouldn't see this. So you may have like a number of frames that the user has to step through. That's an abstraction. And maybe sometimes they want to see it, but 99% of the time they want to see their own code. There's other things like ability to annotate a stack trace so that if there's async code, you can basically stitch together a bunch of stack traces. And this is information that I have as a framework developer because I'm the one doing the deferral. So I do a lot of crazy stuff in Ember, but even simple things like jQuery and Backbone would benefit a lot. And I think, as far as I can tell, there's basically been essentially no work done on this area when there's been a lot of work done on a lot of things. So of course, it's possible to say, well, this is a low priority, but I think given the amount of people that use dev tools and use frameworks and libraries, I think it would be very beneficial.
Yeah, I think another thing that would be pretty cool is better cross-platform dev tools. So each of the platforms has their own, somewhat good in some cases set of dev tools, but then you have to learn something completely different. And so if there was, I don't know, maybe there's standards in the works. You seem really anxious to talk about something, but I mean, you could say the same thing with the native mobile layer, which we're not really talking about too much right now, but it's also obviously important right now in history.
I'm very anxious to talk about it because people ask this question a lot for Firefox mostly, since we're still catching up with, obviously, with Chrome DevTools. So like, oh, why don't you just use the same debugging protocol? Well, this is not going to happen anytime soon, mostly because both Chrome and us and, I don't know, whatever Internet Explorer has, we all want to iterate really fast, and we have different priorities. For us, for example, I just want to describe why this is why the standardization of the remote debugging protocols is not happening right now. For us, for example, the Firefox OS is a priority, right? So what we are working on, like among other things, is the ability to send files or giant blobs over the protocol. Giant multi-megabyte mscript and generated files is also a priority for us. I don't know if it's priority for Chrome, and it might not as well be, and it's cool, but if we will start converging the protocols and doing any kind of standardization, this will slow everyone's down. So the solution to this, I think, and I asked my team yesterday, so kind of my team's solution is to write a shim to a protocol. So when the time comes and we want to use our protocol, our developer tools for Chrome, for example, we can write a shim that will just make a bridge between two protocols, and then we can do that.
So just quickly, it is going to be standardized. TC39, and I know folks at Adobe are trying to take the lead on that. And yes, it's not going to happen anytime soon. I totally acknowledge that. But it's kind of ironic. I don't often do this, but I'm going to praise Java. Java did this, right? Like, it has debugging as a part of the language first class, and JavaScript does not, and hence here we are. And this is desperately needed to have third-party tool ecosystem that sits outside of the browser. Right now, it's almost a browser differentiator.
I would second, though, that the standardization is going to slow us down. We don't want to evolve as fast as Java. We want to evolve a bit faster. And when we were only in the beginning of our journey, there was a protocol, there was Scope, Biopra, and we didn't adopt it. We came up with our own thing, and our thinking was we need to do it as fast as possible and as convenient to ourselves as possible, as close to the underlying system as possible. So you would see that our network domain, for example, is very much WebKit specific. It has things like loader IDs, resource IDs, which are not used in Firefox. So the concepts are different. And of course, we were thinking if it becomes a big thing, we'll be standardizing, but the further we are ahead in the process, the more chances that the protocol that we implemented natively becomes the de facto standard. And I could understand kind of willingness to do the same thing again. And we were also thinking that shims and adapters in the protocols on the JSON level or wire level will solve it, because debugging domain is very conservative. You just step through stuff, and you don't do anything fancy. And once you start doing anything fancy, it starts to differ from browser to browser. So we are still waiting for a number of big players to become clients of several browsers, to see that there is a need for that, there is an investment to it, and then it will be a clear signal that there is a need for such a standard.
Yeah, I don't think one comes at the expense of the other at all. And just to throw some weight behind Yehuda's comment, I think it's well beyond time that we have better instrumentation points into the browser so that we can see the frameworks start providing better hooks. Because the abstraction layer, nobody wants to step through jQuery. That's insane.
Sure. So we've answered 2 questions. We don't have a ton of time. If we can move it forward. You want to take the final reply on this, then we'll move on to...
The final reply, it was, what do you want from tools? So whatever you want from tools, please file the bugs. We are bugs-driven, crbug.com. If you are a framework author, please post to all of your framework clients to start this bug, and we will have no other option other than implementing it.
There you go. There's how you can force your way. Before we're forced into our final our countdown, I want to make sure we at least give the audience a chance to ask a question directly. So, is anybody who has a question in the space of tools and tooling? I was told there were a lot of questions. Any questions here? Here we go, right here.
Ben Diltz from Lucidchart. One thing that's been a real challenge for us over time is trying to collect error reports in production, right? So. You know, like in the closure library, there's something about like an error collector, and it has very widely varying usefulness of data that comes out of that based on what browser or what version or what have you, and it's almost impossible to get a stack trace of where you currently are because you have like the caller on the function, but obviously once you have a circular reference. Anyway, so is there some master plan for making that better? Because it's really terrible right now.
I'll start answering. Everything is very sad. So when I was working at Discuss, we had this problem where we wanted to send reports, and everything was really sad. Now I checked actually a couple of weeks ago because a friend of mine asked, and across the browsers, it's pretty good in Chrome. I think it's kind of good in Firefox, but when you get cross-browser, it's really basic, and unfortunately, this is not what developer tools team can fix at Firefox. This is I don't know, it's either DOM or language design thingy, and with DOM, you have WebIDL, and then you start to cry.
What about tow truck?
Oh, our thingy?
Yeah, your thing.
Yeah, it's pretty cool.
Right.
So,
collaborative debugging.
Yeah, one thing I want to say is that it is even more important for mobile development, because there, when you have an error on the desktop, you're like, oh, what are you using? I'm using Firefox 21. Okay, you'll launch out Firefox 21 and try to reproduce. On mobile, what are you using? Oh, I'm using this Firefox on Android. I don't know what are the versions. I'm an iPhone user, 2.4 something. And then you cannot really reproduce it. So the best choice is to collect data and send data to the server all the time on the background about every stack trace and stuff. And I was helping my friend on Sentry to do it for JavaScript, and that's why I was really anxious to answer that. You should bug everyone you know at the browser vendor to fix that. You should just not stop. You should demand this, because this is really embarrassing for the web that we cannot send a stack trace to the server normally across the browser. So I'm just acknowledging, and I might be fired.
I also agree, and I've raised this a few times on TC39, and there is a low appetite for standardizing stack traces, but I think this is a mistake. So the issue to get past is that when you standardize stack traces, you are forcing the VM authors into a particular pattern of how they have to collect and maintain their code, and this is not a good excuse, and I agree with Anton, you should make sure that all the browser vendors and VM implementers that you know that you don't think it's a good excuse. This is probably, it's like the first step of debugging. It's like before printf debugging is give me a stack trace, and we don't even have it on the browser, and it is probably sufficient to leave open a little bit of wiggle room in terms of what exactly you are required to do, but having some notion of some standardization here would be very helpful, yes. People should ask.
So I've got the 5-minute warning, which means it's probably time to take our 30-second answers. So I hate to be repetitive to the other panels here, but there's not many better ways to wrap up than to ask you guys, with the perspectives represented here of both tool authors and consumers and platforms. If we were back on this stage a year from now and we're talking about tooling and testing, either one given the subject, what is the thing you would hope is most changed a year from now? There's a lot of things that need to be done. We've been told it's a very sad state of affairs right now. It's a very depressing panel. But what is the thing you would hope a year from now is not depressing relative to today? And we'll just run down the line.
Let's just be better tooling.
That's your job, right?
Right. So and we'll make that. So imagine you're running your app. 30 seconds, right? You're running your app, and you can go forward and back in time, explore everything that was consuming time, all of the causes, fix them live, replay thing, it works faster, then make sure that it doesn't regress. Just a miracle.
So that's May 16th, 2014, and we've got a commitment here. All right.
The answer I used to say to this was, some browser, any browser, pause on Stack Overflow. Thankfully, Firefox does it. Chrome, please pause on Stack Overflow. This is ridiculous. But in all seriousness, what I want in general is just more ability as a library and framework author to control what it is that the tools are showing to my users, because having my code be essentially treated as equivalent to their code is really not a good experience, and it is, I think, beyond a small issue.
So I'll understand in terms of mobile tooling. I think it would be really nice, and I know both Chrome and Firefox working on that, is to lower the barrier of entry to the actual to using the dev tools. The fact that we require, that Firefox requires web developers to install Android SDK and use ADB to connect to Firefox to Android to debug their goddamn web application, it's insanity. We shouldn't. There should be a Firefox add-on or something, Firefox plugin or Chrome plugin that says, okay, now you can connect your device, now you're all good. So and we're actively working on that. Someone told me today that Chrome is working on that, so it's really good. And hopefully, in a year or less, we'll have a much lower barrier of entry for web developers to actually use tools to debug mobile websites.
Taking a more testing perspective, what I want to see is you check code for your iPhone application, your Android application, and your web application into GitHub. Your continuous integration pulls that down. All 3 versions of the application are built. All 3 versions of the application are automatically tested using the one single test suite, not 3. And then it's built, signed for deployment, deployed to your fleet of beta users, and then given some standard metric that you're tracking, automatically deployed to your app store or to the web. I think continuous deployment integration for mobile is awesome, and it's not there yet.
Fuck, I'd love that. Good luck. So there's like 2 ways to look at the whole problem. Steve Souders has this awesome article about how the mobile web is getting faster. It's like something, I don't know, I can't remember. It's a percentage faster. But the problem is developers are still writing bigger and bigger web apps. The web apps themselves are getting bigger. And so the performance gains on sort of the platform side are being lost due to the weight. And so to me, I view it very much as a bit of a documentation issue that we got to get in front of developers and tell them to start measuring their stuff so that they start actually, building improvements themselves. Instead of just, loading a whole bunch of script tags and large images, they have to start thinking and cognizing about how they're going to architect their apps. That's what I hope for.
Cool. So on that note, thank you, panel.